Hello, and welcome to this short video presentation, How to Unclog a Flow Cytometer Part 3, presented by the International Society for the Advancement of Cytometry and CytoU. In this short multimedia presentation, a systematic breakdown of the common steps towards unclogging a flow cytometer will be described. Although the specific examples given may not apply to all instruments, the methodologies described should apply to any flow cytometer. Always consult with your instrument's manufacturer for guidance and do not attempt any procedure which may void your service contract or warranty. My name is Jellison, Director of Flow Cytometry at the University of Connecticut School of Medicine, and I'll be your narrator for today's presentation. In this presentation, I will discuss common troubleshooting techniques used to identify and eliminate clogs in a flow cytometer, starting with the simplest and least invasive methods, and moving towards more complex and more interventional methods. May we never forget Shapiro's first law of cytometry. A 51 micron particle clogs a 50 micron orifice. Part 3. Mechanical Intervention. The most disruptive solution for elimination of a clog is to disassemble the sample injection port and mechanically remove the clog. Clog removal can be achieved using sonication of the sample injection port apparatus, using a syringe filled with cleaning solution, or using a steel stylet. Warning: do not attempt this procedure unless you have received permission to do so from your facility director or instrument manufacturer. Always wear appropriate personal protective equipment prior to interacting with sample fluidics. In this example, we will show you how to remove and disassemble the sample injection apparatus from a commonly used analyzer. Before you begin, be sure the instrument is on standby. Unscrew the lock ring from the top of the injection port. Grip the sample injection apparatus by the cone section and firmly pull straight down. Continue pulling straight down until the metal tube is completely clear of the instrument. Note the location of the notch at the front of the sample injection apparatus, which corresponds to the tab at the entrance of the flow cell. Ensure that all O-rings remain attached. With the sample injection apparatus out of the instrument, take special care not to drop or impact the apparatus onto any surface. Remove the outer sample injection port tube by unscrewing the cone. Then gently slide the outer tube off of the inner tube. We will present three options to remove a clog from the sample injection tube, in order from most gentle to least gentle. First, try sonication. Immerse the entire inner sample injection apparatus in a water bath sonicator, and sonicate for 30 seconds or more. As a second option, modify a butterfly syringe by cutting the tubing just above the needle. Then, push the flexible tubing onto the flat end of the inner sample injection tube. Fill the syringe with cleaning solution and connect it to the lure fitting of the butterfly's tubing. Depress the syringe plunger, forcing cleanser through the inner sample injection tube. As a third option, carefully run a steel stylet through the sample injection tube by inserting at the flat end and pushing in the direction of flow. Be sure the stylet does not have any bends or kinks. If you feel any resistance, immediately stop and consider using one of the two previously described methods before retrying the stylet. Upon satisfactory cleaning of the inner sample injection tube, rinse the whole apparatus in purified water and gently dry with a lint-free absorbent wipe. Reattach the outer tube to the inner tube and tighten the cone fitting. Carefully reinsert the sample injection apparatus into the flow cytometer, taking care not to bump the end into anything as you do so. Gently push straight up until it is flush, and be sure the notch aligns with the tab. reinstall the lock ring and tighten firmly. At this point, you will want to prime the instrument to remove air from the flow cell. On some systems, the entire sample injection line can be replaced in the event of a major clogging event. In this example shown here, sample delivery is controlled by a pinch valve, which may be a point of accumulation for clogs. Prior to replacing the entire line, consider massaging the tubing at the pinch valve in order to release the clog. In addition to clogs in the sample injection port, cell sorters may also become clogged at the droplet nozzle. For either a stream-in air or flow cell-based sorter, the easiest way to dissolve a nozzle clog is through sonication. Before you begin, be sure to use appropriate standard operating procedure for the containment of aerosols prior to accessing the nozzle or sort chamber of a clogged instrument. Remove the nozzle from the flow cell and place it into an appropriate vessel for its size. Here I'm using a standard 5 ml polystyrene tube for a ceramic nozzle. Fill the tube with purified water until the nozzle is completely submerged. For certain nozzles which have affixed O-rings, it is important not to use any detergents or harsh cleansers which may dissolve the nozzle's O-ring adhesive. Cap the tube and place the entire tube into a water bath sonicator. Run the sonicator for 30 seconds or longer to dissolve the clog. Remove the tube and nozzle from the water bath sonicator, and again, follow standard operating procedure before opening the tube in order to avoid exposure to aerosols created during sonication. Drain the water and nozzle onto a lint-free absorbent wiper, inspect the nozzle's O-ring, reinsert the nozzle, and check/adjust the stream as needed. As with any assay, reproducibility is key. This too is true for procedures as unglamorous as clog removal. To this end, it is important to verify that the instrument has not changed in any way as a result of your intervention. Ideally, you can rerun a sample that was successfully run before the clog occurred, but in the absence of such a sample, control cells such as glutaraldehyde-fixed chicken red blood cells, leftover compensation control samples, or even quality control beads can be used to verify the instrument's performance. In a pinch, you might elect to run an aliquot of a new sample to verify that the clog has indeed been removed and your instrument is performing as expected. We have reached the end of this presentation. Thank you for tuning in. If you haven't already, be sure to check out parts 1 and 2. And for more great cytometry-related educational content, please visit us on the web at cytou.org. On behalf of the International Society for the Advancement of Cytometry, thanks for joining us.